So in this problem, we're given that an empty truck trailer with a weight of 17,000 pounds is subjected to the wind forces shown below. Assuming the weight acts in the middle of the trailer, what is the expected normal forces at the tires on the left and the right? The tires on the left and tires to the right. So for this is like an equivalent point load idea. So we're going to want to find the equivalent point force and where it is on the truck. So we have this is our like function here. So this is what we're going to want to find the equation for. So if we have our x-axis pointing up, like along the side of the trailer, and the y-axis pointing out, kind of like towards the left of the trailer, that can be how we orient our equation, orient our distributed force. So from this we're going to do rise over run. So we go up 300. We go up 300 pounds per foot over a span of 9 feet. So that ends up being 100 over 3, and that's our slope. So that's going to be, this is our m value, and our f of x equals mx plus b. And then our b is going to be 400 because we're starting, this is where it intersects the y-axis. This is our b point. So b is going to be 400. And then that gives us our function is f of x is equal to 100 over 3x plus 400. Okay. And then from there, we're going to want to take our distributed, we're going to want to find the equivalent force. So to do that, we're going to do force equivalent is going to be equal to the integral from 0 to 9, and that's because our distributed force starts at our 0 point right here. This would be our 0 point, and goes the whole way up to 9. It's spanning over 9 feet. So for our coordinate system for our distributed force, it's going to start at 0, go all the way up to 9. And that's going to be why we're taking the integral from 0 to 9 of 100 x over 3 plus 400. And then that gives us 50 x squared over 3 plus 400 x, going from 0 to 9. So what we do there is we're just going to plug in our 0 and 9, which 50 times 9 squared by 3 plus 400 times 9. And if we plug in zeros, we're just going to get 0, so it's just going to be minus 0. And then we find that our equivalent force is 4,950 pounds. So that now that we have our equivalent force, we're going to want to move on to our where it is, our the point where it's distributed. So that's going to be our x equivalent, and that is also taking the integral from 0 to 9 of 100 x divided by 3 plus 400, and we're multiplying that all by x for our equivalent point. And then we're going to divide that by our equivalent force, 4,950 pounds. And we're going to go ahead and solve that. That's going to give us, we're going to be taking 100 x squared over 3 plus 400 x from 0 to 9 over 4950. And then there, that gives us equal to 100 x cubed over 9 plus 400, or sorry, 200 x squared, and that's going from 0 to 9, or 4, 9, 5, 0. And then same thing, you're going to plug in 9 for the x's and then 0 for the x's. And that's going to leave us with our equivalent point. That's equal to 4.91 feet. So now we have our equivalent force and where it is on the truck. So from there, we're going to want to redraw our free body diagram. So now we're going to want to draw our free body diagram of the truck. So first, we know that its weight is acting in the middle of the truck. So the middle is going to be like about right here, and we're going to have this 17,000 pounds acting down directly in the middle. And then we're going to have our reaction forces of the tires, the left and right tire. So this force, we're going to call this force A, and this force on the right tire is going to be force B, and they are 4 feet from the center of the truck. So the truck is a total of 8 feet wide, and those reaction forces are going to be we're just going to add them to the ends of the tire so that they're exactly 4 feet from the center. And then from there, we're going to take our equivalent force and our equivalent point load, and we're going to put that on the truck. So we started, when we were thinking about the distributed load, our 0 point was right here. And that's 2 feet from the bottom of the tire. And then our equivalent force, 4,950 pounds, is acting 4.91 feet from the point where we said was 0. So we have these forces, and then we're going to have our friction force from the wind is pushing this way, so we're going to have a friction force acting this way, and that's going to be over here on this side. This is going to be acting opposite of the equivalent force, and that's our force of friction. So here we have our different forces acting on the truck, and we can go and we can do our free body, or we can do our equilibrium equations to solve for the unknowns. So we can first do the net forces in the x direction. So that's going to be our positive 4,950 pounds, because we're treating it, if it's moving to the right, it's going to be positive, minus our force of friction, and that's going to be equal to 0. So right off the bat, we know that our friction force of friction is equal to 4,950 pounds. And then we're going to have net forces in the y direction, and that's going to be the force of the weight, 17,000 pounds, plus, and that's going to be negative, it's pushing down, plus the force of one tire plus the force of the other, and that's equal to 0. So we have these unknowns, but we still can't solve for them, so we're going to take the moment at A. So moment at A, and so we're not going to take our FA, that's in line with the moment itself. So, and the same with our friction force, it's in line with our point A here. This is our point A. So we can't take those, but we're going to do force B times 8 feet. And that's going to give us counterclockwise rotation, so that'll be positive. And then minus 4,950 pounds times 4.91 feet plus 2 feet, because that's going to give us our distance to A. And that's going to give us a clockwise rotation, so it's going to be negative. And then minus 17,000 pounds times 4 feet. And that's because 17,000 pounds is pushing down. It's going to give us another clockwise rotation, and it's 4 feet from A here. And then that's equal to 0. And then once you go ahead and solve this, when you can take and you can either plug these into Wolfram or solve them by hand, we get that force B is equal to 11,537.5 pounds. And then we take what we got for force B and plug it back into this equation, and we get force A is equal to 5,462.5 pounds. And those are our forces at the tires for our truck.